Next, let's consider example 10 on page 613. We have a fairly long problem, okay? And right now it's already broken up pretty much, and our job here is to put them together, okay, into a big clump. So then, which is, first I should mention that to do that, you absolutely have to make sure that the base is the same. See, it's log base 2, base 2, base 2. If any of them is different, then say if this one's base 3, then you cannot add these together. Okay, you can only add the ones that is the same together or subtract. I mean, that is, the rules over here, it only applies on the condition that they are the same base. Very important, okay? And most of the time that's really not a problem, but it's just something you should bear in mind. This thing had better be the same base, otherwise there's no addition happening. So anyway, now that we know the same base, then we just apply these three principles here and slap the whole thing together that way. First, we'll write down we'll write down log first, of course. So it's log, okay, and the base 2. And then first we have x squared, we'll write that down, plus means a multiplication, right? The plus translates back into multiplication. So we'll multiply by what's in here is x minus 1. X minus 1. And anything multiplied, a number in front of the log translates into power. So you kick this m up there, okay? So the number in front of here is 1/2, so we'll kick it up here. That is, this thing get flown up there like this, okay? This is exactly the same way this thing flies up there. Okay, so we'll put minus 2 up there, so we got this far. Next, the minus 3, whatever. The minus sign means we're doing division, so let's draw the division line. Minus, the thing we're dividing is x plus 3, etc. So let's write that down, x plus 3 squared, okay? Squared. And then this 3 has to be kicked on top. Now at this point, this is 2 times 3, okay? When we kick it on top, what happens when there's another 2 here? You multiply them together. That's because of the rule that, let me see, how would it, what was the variable used before? Well, whatever. Let's say c and d. Okay, so if we have c to the power 2 and then to the power 3, what is that? That's equal to c to the power 6 because it's 2 times 3. That's one of the exponential laws in chapter 1. Please review that if necessary. This then 2 times 3 is 6, and this is the answer for this problem, okay? As you can see, that is correct. The book wrote it slightly differently. There is x squared, that's the same, right? And then the square root, x minus 1 is under a square root. You can write 1/2 or square root, they are the same thing. And then finally, x plus 3 on the bottom has the 6, 2 times 3 equals to 6 as the final answer. And that is, that's the answer for example 10. So as you can see, even though this problem looks long, there really isn't much to it because once you apply the logarithmic rules correctly, the answers usually come very, very fast. So next, let's do, what is that, example 11 at the bottom of the page. And it's the same thing, okay? So let me write that down. So here's example 11, and we do it the same way as example 10. What we're going to do is first, one thing at a time, 2 log x, kick the 2 on top, okay? By this principle, kick this m on top. And that gives us, well, first let's write down the word log. Let's see, okay, log. And then, okay, so to kick the 2 on top, that becomes x squared, okay? And then minus, that's a division sign, so everything here will go on the bottom of the division line. So it's x, so we have a 4. We don't have to worry about the negative sign because we're already taking care of it by doing the division. So it's just positive 4. 4 goes on top here, so we get x plus 5 raised to the power 4. And again, it's following this rule. Okay, what's on the number on the side get kicked on top. And then, okay, so that's taken care of. Okay, finally, this thing, which is a plus, so that stays on top. We'll write this down, 3x plus 5. So 3x plus 5, and then and this number in front, we'll kick it on top, okay? The fact that there's an x in here changes nothing. We'll kick this whole thing up here, which is 1 over x. We'll write it right there, and that should be the answer. See, it's a one-step process. What is the answer anyway? X squared, okay, 3x plus 5 to the power minus x to the power minus 1. Yeah, that is correct. See, is the answers on the following page, and as you notice, is exactly as is. And next, let's what is that? Let's look at example 12. Okay, then let me erase the board first. Okay, next let's look at example 12. It says that the pH, which is an acidity measurement in chemistry, is defined as negative log, that means base 10, of H plus, whatever that is. Okay, let's not worry about what it is. The point is, if the pH is defined as the negative log 10. Now the question is, if the concentration of H, that's in the parentheses, in the bracket, is doubled, then what is the effect on the pH? Well, let's consider that for a moment. Okay, so let's see, what is the original pH? Let's say the original pH is, we'll call it P, stand for pH. Okay, let's say P originally is something like negative log of C. That is what C is. C stands for concentration of pH. Okay, we don't know what it is, but we'll call it C. And so here's the original pH, which is given to us as negative log of whatever concentration of hydrogen atoms it is. Now, if you don't know the chemistry behind pH, that means nothing. Okay, right now we'll just we'll just accept this. Now, if this is the case, the question is then, what happens if the C becomes doubled? Okay, now if C is doubled, then the new P, okay, and new P, it will become, we'll call the new P N, okay, N stands for new. So the new P is going to be the same formula except with double concentration. So we'll write down log of 2C in here. Okay, so that's the new concentration. But what does that mean? It means, how does that compare to the old concentration? Now what that means is, remember, when you multiply things together inside the log, that's the same as splitting them into a plus situation. Okay, so that's what we're going to do. So the new concentration then is equal to minus log, the minus sign stays with each one, and we'll split this into a plus situation of, so the first one is 2. So the first one becomes negative log 2. Or, yeah, well, let's put them in parentheses for now. So we'll ignore the negative sign, okay? So whatever's in here, it becomes, we'll put this in parentheses. So whatever's in, let's work on what's in here and leave the negative sign out over there for the moment. So we have log of, this becomes a plus situation, so it becomes log 2 plus log of C. Okay, remember when you split the log into a plus situation, then you have two logs, log of the first one plus log of the second item. All right, so what does that mean? That is, then we'll put the negative sign back in. That is equal to negative log 2 and then negative log C. All right, the negative log C is the original P, right? That's P. And so the N is P, and then you add this negative number, negative log 2 to it. And that's the difference, okay? So when concentration is doubled, you need to add this number, whatever it is. So the new concentration then is equal to the old concentration. Here's P, okay? We'll write this down as P. I need to hold the marker just right. Okay, P, and whatever this thing is, and let's calculate this thing. Okay, please type negative log 2 in your calculator, and this is our N equal to, we just need to figure this out, okay? So let's type it into the calculator, which I will do it right like this. So we have my negative log 2 equals, negative log 2 equals 0.301, negative 0.0301, which I will write it down here. Okay, minus 0.301. That whole thing, including the negative sign, is p. See right here. So that is the answer. In other words, the new pH is going to be the old one subtracted by 0.3. That will give you the new pH. As you can see, when the concentration of the acidity, the hydrogen atoms, are doubled, the pH only goes down by 0.3. And that's because the pH is done on a logarithmic scale of base 10. Excuse me. Okay, so that is that's that. That's one of the few things that that I can think of that still use log base 10. And that's from due to historical reasons, okay? Because people used to use log base 10, so they continue to do so. So we still have it defining the pH or the earthquake scale, but other than that, is not really used much. And most of the time we use the natural log. And then next, let's look at the bottom of this page, 14, and there's a formula for changing the base of a logarithm, and I'm gonna show you why the formula works. Now to show this, to prove this formula, let's look at this thing. We have what is that? Log let y equals log base of m. Okay, that's here's the principle here. We'll write this down. So first we have b to the y. We'll define b to the y equals to m. All right, and as a result, then we'll plug y out. Then from that information, we get y is equal to log base b of m, right? And that's the definition. That is b to the power m, b to the power y has to equal to m, according to this principle here. Now and then we're going to do a bunch of cute little manipulations, okay? And then, so what? Then it means that, and that is the base b. Next, we're going to think of something that's base n, where n is different from b. What will happen then? Let's take the log of this thing, both sides with something called log base n. N is a different number than b, okay, a different base. See, this is log b, and we're going to do log n for a specific reason, okay, by. And then, so if you do that, I take the log n of this side, we'll do the same thing to the other side to be fair, big n of big M. So this equation holds because I'm taking the log of identity objects, okay? I already said that they are the same. So the next step is then we will kick this exponent down from here to the in front, okay? So this will go in front, all right? So that is y log n equals to base y, okay? And this side hasn't changed yet, so that's still equal to log n m, etc. And the next step we are gonna do is let's see, I lost my page. Here it is. Okay, so the next step we are going to do is we are going to isolate the y, okay? So, and which means we're going to take this and push it on the bottom of the equation side. So y equal to, here's the numerator, okay? And push this down below, push this whole chunk here down across the equal sign to the other side of the equation. And then there's n, m, and then so this whole thing goes down to the other side, log n by. Okay? And pretend that this number is, say, 2 or something. Okay, if 2y equals to that thing, what's y? Well, then you will be dividing by 2, right? Now this thing is a bigger chunk, changes nothing. You'll be dividing by it to isolate y. Okay, so we got y is this thing. But we already said that y is this, right? What's y? Y is log bm because of this equation. So then finally we get y equals to log b and m. Now, okay, so what have we, what does that mean? That means that if you take the log of some random base, okay, you can, of m, you can change, sorry, let's see, I forgot to erase this, because once I kick the y in front, I need to get rid of it. Why is it still there? It should not be still there, because I kicked it over here, right? Yeah, okay, that's better. So then once you, so what this equation means is, if you have a random base, like for example, let's make up some numbers, okay? Let's say we have log 2 of 5. Now, there is nothing, no button in the calculator that tells you how to calculate log base 2 of 5. You can't do it. However, this formula means that we can change this. This is the same as log big M, okay, divided by log of big M is 5. Divided by log of 2. And the log without the number means base 10. What happens is this equation or formula means that you can take log with some random base and translate it into, that's the same as log of this number, okay? Divide by log of the base, if your log is base 10. Now then, what that means is you can calculate a log with random base with this formula, because base 10 log is in the calculator, okay? So to calculate log 2, 5, you do log 5 and then divide by log 2 and you're done. So there's a very a quick, easy way of doing the of calculating on the calculator any log that isn't base 10. We have, the calculator has 2 buttons, base 10 and the natural log, okay? And that's it. But see, and but you don't need, well, any other base, you don't need the calculator button, because you just pull this trick right here. Okay, just take the base 10 log divided by of the number, and then divided by the log of your base. And that this is also true if you, it doesn't have to be log base 10. It can be the natural log. Either one will work, because we said that any n, okay, will work. So it can be 10 or e. Well, most of the time we probably use e, because e is the most popular logarithm and nowadays. I'm missing my lid, huh? I'll think about that later. So that is that for, and I lost my page. Here it is. So this is a handy thing to do. So as an example in the book at the bottom of the page, see, the book made up some random problem. Say, let's say you need to calculate log base 5 or 36. You just punch it in the regular log base 10 button on the calculator, okay, log 35, then push divide by log 5, and then you get the 2.22 thing. So please do that right now. Okay, logarithm isn't particularly hard to do, I don't think, but I want to show you anyway. Maybe because, okay, let's do this, okay? So we'll do log of 36, and then, is that right? Yeah. And then close parentheses. Do I need close parentheses? Maybe. Okay, we'll close parentheses to be consistent, divided by log 5. Okay, and that looks, I don't think I need to close parentheses. I think it knows that. Yeah, so 2.22, etc. Yeah, just like the book says. So it must be right. Now so that is that's that. Okay. So that's the general thing for change of base. This formula isn't used as much, because how often do you want to change base? Not that often. Like I said, we mostly focus on base e. okay? But it's there if you need it. But the most important formulas for logarithm is these three things: the plus, the minus, and the power, okay? So keep these things strictly in your mind. And logarithm is easy to do, but as a result, they're also easy to forget. See, even if you do a lot of practice right now, give it a month to a year, and then if you haven't done it for a while, then you sort of this memory might start being fuzzy, and you remember like which one's plus and which one's minus and whatever. Now the trick is to keep this in your cheat sheet. Okay, right? These formulas are very short, so keep it on your cheat sheet so that they are readily available. Always keep this in your cheat sheet all the way through calculus because you're going to need it, okay? Logarithm is very important, and most of the time you're going to be doing this. So keep this very clear and refer to it whenever your memory feels fuzzy, or whenever you run into the logarithm and you haven't done it for a while and you can't remember exactly how it goes. Take a quick look at this and you will refresh your memory and you'll be good as new. All right, so that is that. Next, what are we doing here? Let's look at the next example on the following page. Example 13. Yeah. Now, example 13 just says, all right, that's straightforward. It wants you to do log base 5 of 3. Now, it has the formula we just proved, that log base 5 of 3, you just take the log of the 3, okay, divided by log of 5. And they use the natural log here, that changes nothing, okay? Like I said, it's log of m, this number, divided by log of the base. That's how you calculate this thing. So that's example 13. Next, example 14 was that a similar thing, okay? Now we have example 14 on the following page where you're supposed to calculate log base 2 of 10. Well, then you just take, in this case, you punched in ln. It doesn't matter which one you use. It will give the same answer. You can use the log or the ln, either way. Anyway, so in this case, the book used ln, which is fine. And you punch it in. Actually, how about we punch it in right now? Yeah, so please pull out your calculator and let's type this thing in there, okay? We have log base 2 of 10, which is natural log. We'll use the natural log this time. Natural log of 10, 1, 0, close parentheses, and divided by natural log of 2, divided by ln of 2. Close parentheses. Okay, we'll just call that. That should be good enough. And it's 3.3. Yep, that's correct. See? And so anytime you do the base thing, you take the log of this number, push in the calculator log of this, divide by that. And use either the base 10 or base e. But make sure you use the same one, okay? Do not mix up the two. That'd be ridiculous. So pick one and use it to do the division, and that will give you the base of any random base. And then we have come to the end of this section. Now, I want to mention that in the previous section, I mentioned something about the base 10 being the common log, because back in the day, okay, what people did is when you have to multiply something that's a real pain. For example, let's say we want to multiply 1, 2, 3, 4 times 4, 5, 6, 7. Let's say, okay, this is gonna be a total pain to multiply together, right? Especially if you add some decimal points, that's even worse. Okay, I mean, things are getting worse all the time. Now, the way it was done back then, the reason the base 10 is common log is what you're gonna do in the good old days is you take this thing and you look in the log table. That is, you figure out what log of this thing is, and there's a system that you can check it in the table. It has all listed. So then that gives you some kind of a number. I don't know what it is. Maybe so log of this is let's say it equals to I don't know what it is, but so let's say call it A. Okay, so this call it A, and then this. Sorry, let's call this number. Once you take the log, this becomes that is log of this thing is equal to C, let's say, and similarly log of what's on the bottom is equal to D, okay? And then what happens is then the logarithm of multiplication translates into addition. So then you add up these two numbers, which is much easier than multiply these two things, right? And that gives you a sum. And then once you C plus D, let's say it equals to G. Now, once you get the G, then you look at the reverse logarithm chart or something. I don't even know if it's reverse. Anyway, so you look at backwards and figure out if if logarithm equals to G, what's the original number? Then you convert it back, and that is the product, because what you're doing is the logarithm translates multiplication into addition. So then it makes extremely hard multiplications easier, because then you do a conversion, addition, and then conversion again, which is much faster than doing this. And it was which was very useful back in the day before we had a calculator. The answer to doing that is, of course, not exact, okay? And you would have some kind of approximation, but that's all you need anyway. I mean, when you multiply these things together. However, it was an extremely painful process to me that I was forced to do, okay? And even though I had a scientific calculator, I mean, we all did at the time, but my school decided that it would be good for us, build our character and stuff, to learn how to use the logarithm charts. It was like the worst, okay? Life was very bad in the good old days. Anyway, but life is much better now, and you don't have to do any of this. But I'm just saying this to explain why the log used to be the common log, because people did use it all the time if they ever need to do this. And when do you ever need to do this? Probably back in the day, I would say sailors have to do their calculations in order to sail around, that sort of thing. Anyway, and I think the word log comes from sailing somehow, keeping records, well, whatever. Anyway, we don't have to do that anymore, okay? And which is why I think the common log isn't, that is the base 10, is not as common now as it used to be. And so that's that. So let's look at the homework. So for homework, please do problems, let's see, 25, 27, 29, 31, 32, 35, 37, 39, and 41. And of course, do all the examples. You can skip the last two examples because we already did it in the video. If you haven't done it, of course, please do them. They're very fast. You just punch it in the calculator very quickly. So then, and then after you do finish the examples, then you can do the homework and know how to do them. So let's see. And so when you're done, I want to talk about some of them, the homework. All right, now that you're done with the homework, let's look at some of them. I want to talk about problem 29. Problem 29 gives you some conditions first. Let's assume that log base 5 of 6 equals to A. Okay, similarly, base 5 of 11 will be equal to B. What we're trying to do is figure out log base 11 of 6 over 11, and your answer has been given in terms of A and B. That is, your answer just have A and B in some kind of combination, and that's it. You don't have to do anything else. Now okay, so to do that, then we will apply all the logarithmic rules and see where it takes us. First, we have log of 6. Okay, we have log is base 11, and 6 minus. Well, being that this is division, we'll use the division rule, which means that division translates into subtraction, minus log, log 11, log of 11. All right, and then what we're gonna do is use this rule right here. That is, log of base to m is the log of m divided by log of b. Okay, natural log or regular log, common log, doesn't matter. So we'll apply this rule right here. Okay, so this part equal to log of 6. So what's in here goes on top. Log of 6 divided by log of 11, minus this one the same way. Okay, what's in here goes on top. log of 11 divided by log of 11. But that is just 1, because eventually, what does log mean? Log means 11 to what power equals to 11? The answer is 1, and it's also shown here. This part is just 1. All right, so the answer will be log 6 divided by log 11 minus 1. And we'll write it down in A and B form. Log 6 is A. Let's write that down. Log 11 is B. And then minus 1. And that should be our answer for problem 29. And I checked the answer, and it is correct. Okay, so that's good. Next, let's look at problem 31. All right, this is problem 31. We're supposed to calculate this mess without the calculator. And how is that supposed to happen? Well, anytime when this happens, the problems are arranged in a convenient way so that it's easy for you to figure it out without a calculator. Okay, so let's look at this. Well, we have a log base 8 of 2. There's a 6 in front, so we'll kick the 6 on top here. Following this rule, okay, kick the number in front of the log on top as the exponent. So this part equals the log of base 8 of 2 to the power 6. And, okay, what's 2 to the power 6? That is 2 to the power 3 is 8. Okay, so this is 8 times 8. Yeah, so 8 times 8, which is, let me wipe this. This looks terrible. Anyway, 2 to the power 6, that's 8 times 8, that's 64. Okay, so I'll write down 64 here and then move on. And then this one is 8. It's the same thing, right? It's also log base 8, 64. So we'll write that down for now. Log base 8, 64. And then this one, we'll kick the 3 on top of the 4. That is log base 8. 4 times 4 is 16 times 4 is also 64. 64, right? 4, 4, 4. 4 times 4 is 16. 16 times 4 is 64. That should be right. Okay, so that's what happened when I kicked the 3 up here to be a 4 to the power 3. But this is the same thing. So this is just 1. Okay, so this becomes plus 1. And what's this? This log 864 means 8 to what power equals to 64. Okay, that is b to what power equals to the ones inside. 8 to what power equals 64? That would be 2, okay? Because 8 squared is 64. So 8 squared equals to 64. So the answer of the logarithm is 2. Okay, that's the value for x. And so if that's the case, this is 3, and that should be the answer to this problem. That's why you don't need the calculator, is because the whole thing is arranged conveniently for you to come out with the answer without the calculator. So let's check problem 31. Am I in 31? Yeah, the answer is 3. That's correct. So that's good. And with that, let's move on to the next problem. So next, let's do problem 32. Well, this problem is, first you see 2 log 9(3) minus 4 log 9(3). They're the same thing. Okay, it's both log 9(3). So we will have just 2 of them, -2 left. Okay, so let's remember that. This minus that equals a -2 log 9(3). But we'll ignore that for a moment. Okay, actually we'll write it down. -2 log 9(3). All right, so next is this thing right here. Now what is that? That is the same as negative, because this is on the bottom. Okay, that's the same as anything on the bottom is the same as 729 to the power -1. Okay, all fractions are the same as the inverse at the -1 power, and we'll move the -1 in front of the log, so that becomes negative log 9. And then 729, okay? And to convert it back, you can just slap the -1 on top here, which turns it into this fraction. So anyway, so we have this thing and that thing, okay? We'll worry about that thing in a second. Well, now what is that? That we can slap the 2 on top here. That is equal to minus log 9 Okay, and then 2 goes up here, becomes 3 squared. 3 squared is 9. Now, anytime you have the same, this value right here is 9 to what power equals to 9? Well, it'll be 1. Okay, 9 to the 1 power is a 9. So this value is only 1. So this part becomes -1. Now this part, what is 729 anyway? We need to factor it, okay? Being that we're not allowed to use the calculator, let's do it the old-fashioned way. We need to factor this thing. Well, the factoring rules, one of the factoring rules says that if you add up all the digits, 7 plus 2 plus 9, okay, if it's divisible by 9, 7 plus 2 plus 9 is 18, which is divisible by 9. That means this whole thing is divisible by 9. So let's do that. What is this thing divided by 9? 7. So let's write it down here. 729 divided by 9, that should be equal to 81. Okay, and what that means is, well, anyway, so what that means is that this thing equal to, so this part is equal to log base 9 of 9 to the power 3, okay, because there's, it equals to 81 is 9 squared, so there's 3 of them here. 9 times 9 times 9 should be 729. If you have trouble doing this in your head or even doing this, feel free to use the calculator to just confirm this part, okay? It doesn't hurt anything. So, and what happens is, and what is this value right here? This value means 9 to what power equals to 9 to the 3rd power? In other words, it's 3, okay? Generally speaking, if these two numbers are the same, then whatever power is up here is the answer. So this part equals to 3. So what do we have? So the whole thing becomes, the answer to this problem should be -1 minus 3, which is -4. And that should be the answer, okay, to this entire thing here. And to confirm that, being that we don't have the answer at the back of the book, we can confirm that with the calculator. So please do that right now. Okay, you don't normally have to do this for every problem. Well, I don't normally assign even number problems, but this one looks interesting, so we're going to do it. So we're going to calculate -2 log 9, 3, okay? We'll skip that part and just type in -2. So I will do it like this. Let's see, where's my minus sign? It's right here. -2, let's see, wait a second. We can't, so log 3 and 9, we'll write it and type it in as log 3 over log 9, following this principle right here. So that is log, we'll use log, -2 log 3, close parentheses, divided by log 9, right? Yes, and close parentheses, and then subtracted by the other thing, same deal. Log of 729, close parentheses, okay, divided by log 9. Yes. Okay, is it a subtraction? Well, let's go, well, let me do close parentheses. Okay, I'll just push the equal sign. Hopefully I typed in everything correctly. Yep, -4. See, that is exactly what I got before. So that must be the right answer, because we are doing this in 2 somewhat different ways, right? Different being ones by calculator, ones by using various logarithmic rules, and they turn out to be the same. So it should be the right answer. And so that is problem 32. All right, next let's look at problem 37. I did not write that down. Okay, this is problem 37. Anyway, so problem 37 is quite short. It says, log base 1/2 of 4.7. So that is by the formula right here. Okay, we'll punch it in. That equals to the log of 4.7 and divided by log of 1/2. Log of 1/2. Anyway, so let's punch that into the calculator. The fact that this is 1/2 changes nothing, okay? You just, and of course you can use either the natural log or the regular log, the common log. I'm gonna use the natural log in this case for no reason at all. And so let's punch in natural log 4.7, 4.7, close parentheses, and divided by natural log. Yeah, make sure you use the same kind of log. Don't change shift midway. So natural log of 1/2, which is 1/2 is just 0.5. So I'm just going to type in 0.5, and then close parentheses. That should be it. That comes up with some kind of answer minus, minus something, 2.23, and that's problem 37. So minus 2.23, that's correct. Okay, so that's problem 37. Next. All right, problem 39 is a bit of a challenge problem in the sense that there is no example that looks directly like this. Okay, we didn't have to do any of that in the examples. Maybe they should have done one to show us how it's done. But it's still okay. We just have to work with it a little bit. So first, we have logarithm on this side and this side, but we have only a number here, okay? And the logarithm here is also always base 6. So let's change this side to logarithm as well. What is 1? 1 is the same as log of base 6 of 6. Okay, anytime these two numbers are the same, the answer is 1 because the definition of logarithm means 6 to what power equals to 6? Well, it's 1. Okay. Alternatively, you can think of it as right here, where b and m is the same thing. Well, if they're the same thing, once you do the division, m and b is the same thing, then the division is 1. So either way, that's how you come out with, we can come out with this. The reason I choose log base 6 is because it has base 6 here and here. So I want every side to have, everything to have log base 6 so that we can, well, get somewhere with it. All right, so next let's condense this thing, okay, and take it all into one big chunk. So we have log of base 6. Of the condensation rule says first, this one is, we'll write that down, x plus 2, okay? And this is a subtraction situation. Subtraction translates into division, right? So we're going backwards, so we're going from here to here. And then divide by what? X minus 3, okay? Minus 3, right? Okay, so far so good. That equals to log base 6 of 6. Now, at this point, we will say that being that these are the logs of the same thing, right? Then what's inside has to be also the same. And so we are going to, then we'll go ahead and take this equal to 6. And in other words, we're going to get rid of the logarithm symbol because it applies on both sides. So we can reasonably get rid of it while being fair. So let's get rid of the log 6. And so we'll get rid of this, okay? Or you can write it in a new line. I don't want to bother. So I'm just going to do it like this. And now it becomes a rational equation that we've done in chapter, was it the end of chapter? No, it's in chapter 2, or, well, whatever. There's some place that we did this, in 1 or 2 that I ask you to review those sections whenever necessary, okay? You must know how to solve this thing right now without me showing you how to do it. But I'm going to show you how to do it anyway, okay? So so then this thing multiply over here, it becomes x plus 2 is equal to 6 times this thing. So it's 6x minus 18. My one is weird looking. All right, so then when you do this without messing up, so this x move over here becomes 5x, and then the minus 18 over here becomes plus 18 plus 2, that's plus 20, so that gives us x equal to 4. All right, so then now that we're done with that, we need to plug it in to see if it works. Because sometimes you might come up with garbage that doesn't work. Well, just to be sure, okay? So when we plug in x equal to 4 in here, that's 4 plus 2 is 6. So log of 6, as always, if they're the same number, is this equal to 1. So this thing is just 1. And then log of 4 minus 3 is 1, okay? Log 6, 1, any log of 1 is always 0 because 6 to the power 0 equals to 1. So this is 0, okay? And then this is 1, so 1 minus 0 equals to 1. So it does check out. So this is the correct answer, x equal to 4. Yep. Okay, so that is problem 39. So problem 41, we need to prove that these two things are the same. Okay, we're going to rely on this thing. Okay, so log bn by this rule here is the same as log n divided by log b. And then this side is, what is that? That is 1 over this thing, this side, so that equals to that. Next, this side is 1 over that thing, which is 1 over, by the same definition, log nb is equal to log, I need to write down my log first. Okay, now log b, this is log b divided by log n. Okay, and that is, so the next step is this is the general division line, right? This is just the fractions being divided by. To divide by a fraction is to invert and multiply. So this part equals to, let's invert this thing. Sorry, I'm missing the log here, okay? Log b divided by log n according to this rule. So let's invert this thing. And that's just 1 here, so you don't have to do anything. And then so 1 divided by this is 1 times invert and multiply. That is 1 times log n divided by log b. But that is exactly this, see? 1 times log n log b is that thing, and therefore we are done proving. And that marks the end of this section.